Welcome. So in this session, we will solve a wave equation for infinite string, and we will use D'Alembert solution, D'Alembert method, in fact, to find the solution. Okay. Now, if we write down the heat problem for infinite string, sorry, wave equation. Every time I say heat, wave equation for infinite string. Okay. For infinite string. Okay. This type is very important for any of the exam. In fact, it appears to be this, where they will give you this x has also the category, and this t is greater than 0. And when it is for the infinite string, most of the time this boundary conditions will initial conditions will be missing. Only they will give you this. Okay. And sometimes they may give you f of x, sometimes they may give you g of x, so that does not make any difference. So you can apply this formula. Okay, so solution by D'Alembert's method is given by, okay, it's simply u of xt equal to 1 upon 2 times equal to 1 upon 2 times, okay, f of x plus ct plus f of x minus ct, and then plus 1 upon 2 c times integration of x minus ct to x plus ct, and then g of y dy. Here I'm replacing the variable we're talking about. Basically, when I'm saying g, then I'm talking about this quantity, but this is a function of x here. But since I'm replacing the variable because I have here in the form of x, okay, so I'm replacing the variable g of y dy. Okay, so that's the solution by D'Alembert method. Okay, now let me consider a problem so that you understand it better. Okay, I'll consider a problem. Okay. So let's take an example here. Okay, say you have a curve, say utt equal to uxx and ux0 equal to sin x and ut at x0 equal to 1. Okay, then what is u of xt? Okay, also find u at pi comma pi by 2. Okay, so that's not a big deal. In fact, we will simply find out the solution by using the D'Alembert's method, and then we will plug in pi and pi by 2 at the place of x and t. Okay, so now if we equate, then you get c equal to 1 because there is no c, so c is 1, and your f of x is sine of x, and my g of y, which is the condition at the derivatives, it is nothing but 1. Okay, so now by D'Alembert's method, okay, by D'Alembert's method, simply just write down the solution. Uxt will be equal to half of f of x plus ct and plus f of x minus ct and plus integral x minus ct to x plus ct, and then g of y dy. Okay, now let us find out. I'm sorry, I forgot to multiply 1 upon 2c here. Okay, it is always there. Fine, now let's solve them. So it will be half of, it will be sine of, because f of x is my sine of x, so x plus ct will basically c is 1, so it will be just x plus t. okay, and plus sine of x minus t, and plus 1 upon 2 will remain here, and then from x minus t to x plus t, just 1 dy. Okay, now we have to open the brackets, so that will give you sine x cos t and plus cos x sine t, and then this another one will give me sine a cos b minus cos a, then sine b. This part is done, and I'll just simply integrate this and get 2 times x plus t and minus x minus t. Okay, so I'm done, and in fact I see that this is getting cancelled, and this quantity will give me sine x cos t, sine x cos t, so it will become 2 times sine x cos t. So I'm getting u xt to be u xt. I'm getting this 2 and this 2 and this 2 will get cancelled later on. Okay, so 2 sine x cos t getting cancelled. Okay, and this part will give us this x will also get cancelled, we just get 2t. Okay, so we just get 2t, so plus 2t. All right, now you can even cancel this 2 and get only sine x cos t, and plus I think this 2 will also get cancelled because there was one more 2. Yeah, so this 2 and this little x and x getting cancelled, t plus t 2t, so 2 will also get cancelled. Okay, so even this 2 is not there. Okay, it will be basically 2 by 2, so this is getting cancelled, and even this is getting cancelled. So sine x into cos t plus t, so that's my solution, u x t. Now I need to find out u at pi and pi by 2. So basically it will give me, when I have put here pi, so this first term will become 0 and eventually lead to the entire quantity getting 0 and just pi by 2. So I just get pi by 2. So u of pi by 2 is nothing but pi by 2. In fact, D'Alembert's method is quite easy to solve, in fact, okay, because it doesn't take much time and gives you the solution in a very efficient manner. And suppose, let's say, if no one asks me what is 0, I mean u of xt, and they just told me to find out u pi comma pi by t, so I can simply do this rather than integrating from x minus t to x plus t and finding all these things. I'll simply plug in pi and pi by 2 here itself, and I'll write down this f of pi plus pi by 2. In fact, I'll demonstrate it, okay, in the same video. Just see. Okay, suppose without finding the solution, I'm just finding directly. Okay, what will be my u of pi comma pi by 2? Okay, let me write down the another approach. Okay, without finding the solution. Okay, another approach. Okay, u of pi by 2 will be nothing but 1 upon 2, and just now I noticed that it's nothing but f of x plus c2. So c was 1, so pi plus pi by 2 will give me 3 pi by 2, and plus f of pi minus pi by 2 will give me pi by 2. So this quantity will become pi by 2, and plus 1 upon 2 will again come to the picture, and then integrating from again x minus ct, that means integrate from 3 pi by 2 to pi by 2. Okay, and just 1, so it was basically dy. Now just simply integrate this, so you get half of now f of 3 pi by 2. Okay, so what is my f? Basically sine x. It is sine x, so just plug in there. Sine 3 pi by 2 will give you -1, and sine pi by 2 will give you 1. So this is done, and now comes this chance, so 1 upon 2. Now it will become pi by 2 minus 3 pi by 2. Okay, pi by 2 minus 3 pi by 2, so that will give you, I think I made a mistake here. I think it is pi minus pi by 2. So basically it will go from pi by 2 to 3 pi by 2, but I have taken 3 pi by 2 to pi by 2, so rather I'll put a minus sign here. Okay, and then this will eventually make this quantity minus. So let me erase this. Okay, yeah. Now this thing will become 0, and I'll get 0 minus, this will give me 1 by 2, and then minus 3, 1 minus 3, 2 pi by 2. So this 2 getting cancelled, and you directly get answer pi by 2. Okay. So that is also one method. Okay, without even solving the whole entire solution, you can simply just put pi to pi by 2 and find out your solution. Okay. Thanks for watching. See you in the next video.